Hello everyone, I am Kathroju Abhilash and from team G667, and today I will be presenting our project Smart Road Damage Detection and Warning with tagline Detect, Warn, Prevent Road Safety Reinvented. Our project team includes ATVRK Kartikeya and Sujit Kumar, B. Akhil and M. Sai Deepak, and our project mentor is Mr. K. Vishnuvardhan sir. Let's get started. Understanding the base paper. So let's begin with our project inspired by base paper called RoadSense AI. The key idea in the paper revolves around ECRD framework, which combines edge and cloud computing for faster and more accurate damage detection. Basically, here it's how it works. Images of roads are captured and processed locally using edge devices to quickly identify cracks or potholes. Then the data is sent to the cloud for deeper analysis and for the long-term storage. This approach helps in two ways. It minimizes the delay or latency in detection and at the same time provides the valuable data for road maintenance authorities. So, in simple terms, the paper focuses on the CNN based model that detects road damages in real life and alert nearby drivers and officials. Our project builds on this idea. Let's move on to the problem definition. In problem definition, poor road conditions are one of the leading causes of road accidents and vehicle damage. The traditional way of inspecting roads, sending officials to manually check for roads, is slow, expensive, and often inaccurate. And project addresses the three major issues: traffic safety. By providing early warnings about unsafe roads, we can help prevent accidents. Economic impact. Continuous road damage leads to high maintenance and repair costs. A smart detection system reduces these costs. Efficiency. Automation using AI is far more consistent than this faster compared to the manual inspection. So, our main goal is to design an automated, reliable system that can detect and classify road damages quickly, accurately, while keeping latency very low, which is essential for real time warning. Let's move on to the scope of the project. Coming to the scope of the project, we are implementing fully working prototype based on the ECRT concept with our own user admin model. Here what it means. The first, let's talk about the in scope. It is a full end-to-end admin workflow deployment of a road classification CNN model and the triggering and the output of the damage CRT model number two and the necessary backend services like Node.js and the database integration. Now let's talk about the out scope of this project. We are just we are not testing the system in the real world setup, and we are and exploring the incorporating the new light models like few short learning beyond the current design. These comes under our out scope of this project. Now let's move on to the fifth slide, which is proposed solution. Our solution modifies the original paper into more practical workflow based system. So instead of raw image input directly going to AI, we added a structured flow. Model 1, which acts as a pre-filter, ensuring only real road images go through. Then the admin manually triggers the model 2, which gives a detailed report, bounding boxes, and damaged areas, and and the type of damage and severity level. This makes the process efficient and reliable because the admin can prioritize which reports need to immediate in attention. By the end of the project, our expected outcome is a system that can accept images, validates and analyzes them, and finally stores the complete report in the database ready to be reviewed or used for the further action. Let's discuss about the tech stack. Our tech stack covers all layers. On the front end, we have user friendly for the uploading images and displaying reports, and the back end is built using Node.js, which handles the request, connects to the database, and communicates with the AI models. For AI, we have used the convolutional neural networks, which are the CNNs trained on the datasets like RDD22 2022, which we borrowed from the Kangol, and our own collected road damage dataset. And for the storage and deployment, we plan to integrate our cloud services for scalability, for which we use Amazon Web Services. In short, our tech stack ensures smooth connection communication between the user, the admin, and AI models and the storage layer. Now let's move on to the architectural diagram. This diagram shows the complete flow of our system. At start, we have user interaction zone where the image uploaded happens. Next, in the admin interaction where the admin can review and trigger analysis. Behind that, backend services built on the Node.js act as the main bridge between the user interface and AI models. Then we have AI models and processing zone where Model 1 and Model 2 perform image classification and damage detection respectively. Finally, the processed results are stored in the storage slash output zone from where reports can be viewed or downloaded. This flow ensures data is handled efficiently with clear separation of roles between users, admins, and AI backend. So now let's wrap up. That is closing. Our next milestone, we aim to complete and demonstrate the core user to admin instigation pipeline. This means a user will be able to upload a road damage, Model 1 will filter it, and an admin dashboard will automatically receive a notification to analyze it and further using Model 2. Overall, our project aims to make roads safer, maintenance smart by combining AI edge cloud computing and real-time data flow. Thank you.